Okay, so troubleshooting, that's one of the biggest things that is very important to do. And we all know that if we've been in the industry for any kind of period of time or we're working with parts and pieces and product, there's always some troubleshooting that's going to happen. And the best thing that we can try and do is to make sure that we minimize some of the product, some of those issues. And one of the biggest things that I've enjoyed in my 7.5 years of Boss Up Boy now is the desire to make these products as best we can. There's over 350 brands worldwide, but to make quality products that, we can stand behind. And I think the fun part that we have out of Phoenix right here is, Russ, Katie, and Matt and I, is that we get to take the simple mechanical parts and pieces and we make them, for the most part, we're going to take it from a mechanical to an electrified format. So, we represent the HES brands, HES Strikes, Securitron mag locks. And next week, just to give you a heads up, next week we have a mag lock class on Tuesday. And on Thursday next week, we have a brand new mag lock scenarios class that I'm working on right now. So a little bit of plug for next week. And then alarm controls and life safety power are the different products that we all get to represent out of Phoenix here. Safety is always critical. Safety has changed and evolved in the last year and a half. So we're evolving, we're listening to what our company standards are, we're listening to what the customer standards are. If we're going to a customer's business, what do they require for us to walk into that business and do work? So safety is always critical. I know that every single morning, I was the first guy in almost every single morning. And when my crews came in, they got ready to head out, I was always be safe, have a safe drive. I want everybody to go home at the end of the day, no matter what the situation is going to be. So here's just kind of a quick look at what we're going to be doing today. We're going to talk about just a little bit about history and then get into some site survey, skill sets, electronic, mechanical, and support. So we know that electric strikes have been around for a long time. We go back into the 1880 time frame when we have that first buzz me in electric strike. We've had changes and evolutions that have happened. We've seen a lot of good and we've seen a lot of bad over historically on strikes and how they're done. Time and patience is one of the most critical things that we have to look at when we're working with some of these products. And if we do it right, I was a manager and I told people, I don't want a return call under service. So if we take our time, do it right, do we push someone to get it done in half an hour when it should take 45 minutes to an hour? I'd rather do it neat and clean and not return under warranty. I have to hope that something like this is done by a maintenance person, that nobody on the locksmith side of the industry or the integrator side of the industry would do something like this, but we see it. And these are going to create problems over time, things that we don't really want to mess with. And I think the other thing that I'm really proud of is I go back to, I remember it was probably around 1996 or 97 timeframe where I actually got my first tour through the HES factory in North Phoenix. The factory was here in North Phoenix, so it's been here for a long time. But the warranty that they put out on their products, even back then in the early and mid 1990s, the first Smart Pack was coming out around that time frame. But the warranty is really critical, and the warranty evolves over time as we change some of the different products. So you can see the two main warranties where we're talking about with electric strikes, and we're going to talk about when do we look at using, the Smart Pack? I mean, the Smart Pack automatically takes you out to a 10-year warranty when you add it on the strikes here, but the Smart Pack has reasons why we use it. And oftentimes they're dealing with potential problems or troubles that we may have in the field as to why we may want to use a Smart Pack. And we're going to talk about that later on as we get through a lot of the presentation. So let's go ahead. We're going to move on and we're going to get into kind of the steps and the processes that I look at when we're going to do, do a site survey and understand, troubleshooting, because my service technicians that work on the service side of the industry were my top technicians. They had to have skill sets above and beyond what an installer did. And that's important because we're going to learn and understand, communication with the customer, listening to what they're saying and, listening to what they're saying is happening or what is not happening, talking to the right person. Understanding, how is a circuit put together? When they walk in and they see an electric strike on a door frame, what type of circuit am I working with? Am I working with a normally open circuit or am I working with a normally closed circuit? Am I working with a circuit wired in series or wired in parallel? And how to use a multimeter is critical. Learning, understanding that the problems may not necessarily be electrical, they may be mechanical issues. and mechanical issues that may also be a part of something that's not even related to the strike at all. You know, something with the door frame, something with the door closer. There are many different things that we have to consider when we're looking at doing troubleshooting and understanding how do I troubleshoot a circuit. You know, hardware, circuits, functionality, always, always understanding what we're working with, and if not, ask questions. And we talk about, our Also Boy customer support app and how important it is to us. And, we think about going back and doing a troubleshooting and, oftentimes, where do we start? We start at that gatekeeper, the gatekeeper who's there at the front entrance, who's going to allow us in. And maybe they know the answer, maybe they don't know the answer. What is the problem? Where do I go to? Or that gatekeeper is going to reach out to the maintenance or facilities person to allow us to talk to somebody, and who's going to tell us what is happening. And what is happening and what is not happening are two of the most critical things we want to know, or what should happen. Those are important things to us that we want to ask as we're starting our troubleshooting process and looking at things. And, especially if I know, if I'm walking in the front door and I know the problem is with the front door, okay, what am I looking at as I come through that door? What do I see as I visually walk through that door? What are the potential issues which are coming up? These are things where I work with my technicians to make sure they're alert. They're alert and they're aware of what we're walking into and understand a lot of things just without even talking to somebody. You have a basic understanding of, how are some of these things going to work? How are they going to function? What type of switches and buttons are going to make them work? On last week we did a class on switches, and understanding switches are so important. Understanding that when I put an electric strike on a frame, it's normally going to be fail secure. My wiring is going to be wired in parallel. I'm working with a normally open circuit. Based on that, what kind of a switch am I going to be working with? Where are potential problems and what are things that I recognize when I'm walking through the doors? These are things where I'm paying attention to that. Because when I'm trying to do troubleshooting, it's listening and understanding circuit. These are things that are right on the top of my head that we should know right away. Mechanical issues, electrical issues. Well, we're going to break it down into a little bit more detail as we do this. And obviously a multimeter, if you're working with anything electrical, and sometimes some of the mechanical things we can see with a multimeter as well, but we have to understand how to use a multimeter. And I think Russ and I both, we enjoy our hands-on class for basic electricity because we get to spend 2.5 to 3 hours working hands-on with our multimeters and with circuits and putting them together. But a lot of technicians today are still missing a lot of basic skills. I always tell everybody that when we're looking at creating a good technician, you're looking at probably 5 to 7+ years of experience to really understand what they're doing and how to do it, or at least how to do it the way I kind of want it done, with good customer service and good technical knowledge of how to use some of it. And if we don't have that, make sure that technician or whoever's going out there has our app on there. If we're working with an HES strike, a maglock, whatever it is, if you need support, this app here allows that technician literally and like 3 touches of the phone of being able to talk to us, communicate with us, talk to us on the phone. If you're on the job site, live stream video to our technicians, and we can see exactly what you're looking at. And you can send us pictures, you can chat with us. And if you need the library, to kind of see, I need the installation instruction. I need the basics of the installation. And we're going to talk about literature and how important literature is as we continue to go forward here. We can get into the resource center and see the literature that is there as well. So I want to ask a quick polling question here. I've got a quick polling question I'm going to ask right here. I'm going to drop it down in just a minute. But when does troubleshooting begin? After the customer tells you what's wrong, as soon as you get on the job site, at the job site before you start the installation, during the original survey. Oh, let me bring up my poll here, and I'm going to, I need my second poll. There we go. Let's go ahead and launch this poll up. And I want to see, when do you think troubleshooting begins? At what point do you think troubleshooting begins? And you kind of have to be in some of my other classes beforehand to maybe realize this, because we teach classes on site surveys as well. And I can see, okay, looks like I've got a couple more people, kind of see if we get a few more answers here. After the customer tells you what's wrong, as soon as you get to the job site, And this is going to have a couple of different answers. So we got most everybody up. I think the others are us sitting here from also Bloy. So I'm going to go ahead and end that. And I'm going to spin it around and share this. And we have to kind of consider if this is a brand new customer, which it may be, you know, brand new customers, I've never been here before. We're taking over somebody else's system, which is very common. You know, we did probably in an average year, we would take over maybe 5 to 10% of our new customer base just came from people we took over from other customers. But at that point, you don't have a history with the facility. But if I own that facility and it's mine and we did the original installation, troubleshooting begins at the site survey, at the original site survey. So there are different times when you're going to see different times where, when does troubleshooting begin? When I'm walking towards the door, I start my troubleshooting, even if it's a brand new door. So I'm going to go ahead and stop sharing this one right now. Let's go ahead and continue on. Okay, when I'm walking towards this door, I'm looking at this door. If I know I'm going to be troubleshooting the front door's got a problem, I'm looking at that door as I walk towards it. And I'm looking at the hinge side of the opening. So here's my hinge over here. And I'm looking at that gap all the way around it. I know in a standard healthy door, my gap should be 1/8 of an inch all the way around it. And this can be influenced by a lot of different factors. And one of the biggest factors obviously is, damage that can happen over time. And we'll talk about that in just a minute, but environmental issues based on where you're at around the world. In Arizona here, we're going to deal with the blistering sun here coming up in the next couple of months, and we're going to deal with that sun until the end of October. So we're going to have to deal with expansion and swelling that happens. Many others, depending on where you're at, you're in the cold environments, the heat and the cold, the fluctuation, the changes of air conditioning and heating, air balances within your building, weather stripping, but environmental and health issues and preload pressure against the latch. So when the door is closed, it's in a latch position. If I've got pressure that's pushing on that door, whether it's from weather stripping, the door is swollen up, some other issue. If I get pressure against the latch, which creates the latch not to be able to retract, or an electric strike not to be able to release because there's pressure from the latch against the keeper, that is where we have preload. If you've ever gone to a door and you try and turn the handle, it's really kind of rough or hard to turn, and you got to push the door in or pull the door out to take pressure off the latch before you can turn it freely, that's preload pressure. And being aware of that is important. We do have a sample video Katie just posted up as well, so you can go watch it. But there are a lot of other issues which are created by doors and hinges and closures and many things that happen. And sometimes we get people that want to try and fix things that just create more problems for us when we're dealing with the access control side of the world. But keep in mind, some of these problems are not ours, and some of these problems are things that we're not going to work on. So there again, the technician needs to understand, am I capable of working on something? Do we do this? Remember, if you touch it, you own it. So I'm always very cautious on that. I'm saying, okay, let's take a look. Can you do this? Can you fix it? Because as soon as you touch it, you own it. Okay. But I also know the technicians who work for me, knowing their skill set, knowing what they're capable of doing, knowing how to use multimeters, knowing and understanding basic circuits. I had technicians who would go out there and literally blow up panels. They would blow up power supplies. They'd blow up customer data boards. It would happen. It's an accident. Learning is one of the most important things that I stress is if you make a mistake out there and you do some kind of damage, you better learn from it, because after 2 or 3 times of repeatedly creating the same problem, the same issue over time, I need to decide if I can afford to keep you on my team, or do you need to go back for some type of other training, but also giving the technicians who work for you the proper resources to do what they need to do, especially on a technician level. They're going to run into so many different environments. Their skill set is so critical, but giving them the right tools, helping them understand how to work with different things, solder and heat shrink, one of my favorite ways, best ways, but it's also time consuming, when you get into doing solder, but having the right parts and pieces and knowing how to use your tools correctly. We use a basic multimeter for training, but many of these technicians will have the more advanced multimeters, the digital multimeters, but there again, it's based on their skill set and their comfort level of working with the different parts of tools that we do have. So understanding the technicians who work for you is critical. We put a lot of pressure on these people to understand the basics, and we're going to talk about some of those basics, because you cannot properly do troubleshooting unless you understand electronics. Electronics are the base for what we're going to do when we're working on any of these components out there. So we want to make sure that we're working on this stuff and understanding what we're working with. Sorry about that. Okay, so understanding circuits is important. Okay, understanding that most times when we're working with an electric strike, standard electric strikes are wired in parallel. They're set up in a normally open circuit. We have to understand how that circuit works, how it functions. Technicians, especially that high-level technician running as a service technician, understands that, knows how to work with their multimeter, how to set up their multimeter. So we understand I've got an open circuit. I've got no electricity sitting down here going to that electric strike. And keep in mind, it's not just electric strikes, electrified lever sets, electrified mortise lock sets, electrified bars. They're the same configuration. I could change that part out right there and put any 4 of those in there. But it's understanding, you know, I need to send it electricity to unlock it in a standard fail secure configuration. Most hardware is set up today so it is fail secure, because if I lose power, I do not want to lose security on that door. So understanding how a circuit can be configured is important. Understanding the switches that we're going to have here. These are things that, like I said, the technician who's there working for me better understand this right off the top of their heads. You know, but we also have mag locks out there, something wired in series. We have a lot of mag locks that are they're still out there in the industry. Mag locks are never going to go away. You know, we're changing and looking how we're using and when we're using a mag lock today, but you know, a mag lock is standard fail safe wired in series. So the breaking of any circuit connection in here breaks power to my mag lock, which is sitting down here. But also there again, I go back to, you know, can we have different configurations for different hardware? Yes, an electric strike, an electrified lever set, you know, some of other products, Adams Rate 4300, they can be set up fail safe as well. So here again, understanding basic circuitry, how something is configured. I expect the technicians to have a very, very, very solid understanding of this. This stuff should be automatic to them when they're understanding what type of circuit do I have? How is the hardware configured? If I understand is that product fail safe or fail secure, I should know the wiring configuration immediately and understand how it works. Understanding how to use my multimeter when it comes to looking at different products. In this configuration right here, I've got set up here an electric strike. So I have an electric strike standard fail secure. I've got 2 switches that activate it. I've got a switch up here, it's a double pole single throw. And over here, I've got a simple NTS1 alarm controls wave switch. These are wired in parallel. And if we kind of work our way through here, we can kind of see I've got a power source here, a power source that's going to bring me power into my switch here. It's going to bring me power into my NTS1 right here. So I've got my positive power right here going into my 2 switches. But you notice right here, my normally open connection, that is a throw from switch 1 and a throw from switch 2 going into this connection point. I bring it over here to this little loop right here, and I'm going to use that as my test point, or I can use that or here for my test point to test my device and seeing how it's working. But I've got a normally open circuit. I have to activate one of this or here to send electricity into my strike to allow it to unlock. So understanding basic circuit development is important. And we talk about that as we, first as we're going to talk about voltage. You know, voltage has been around. We think about going way back into the late 1700s when Alexander Volta gave us a definition for voltage and the electrical force or pressure that pushes current along or through a wire. We have to understand as we work with electricity, and we cover more of this in our base. We have a class on DC electricity that we do separately as well. So if you want to go watch it, we get in a little more detail, but understanding voltage and how it works, understand voltage drop or voltage over. And a lot of times that source of the voltage tells us whether we're going to be over or under voltage. Most access control systems are configured in a 24-volt DC configuration. And we always kind of look at on the manufacturer side of a standard of plus or minus 10% on the voltage to make any product work, whether it's a mag lock, whether it's an electric strike. Our standard is 10% voltage. And in the literature, which we're going to talk about in a little bit, the literature tells us how much voltage this should be working with. It also tells us how much amperage we should be working with. Plus or minus 10%, 24 volts plus 10%, 26.4. minus 10%, 21.6. Those are numbers I expect the technicians to have in the back of their mind. They're there, they're part of it. And when I want to test for voltage, I need to understand how my multimeter is going to be configured. Setting up our meter in voltage and understanding, what am I measuring? Am I measuring 12 volts or 24 volts? Where does my dial get set? Understanding that as I work my way through a circuit, I find a positive, I take my common, I connect it to find a negative point, and then I work my positive side along my circuit. Connection 1 point, do I have voltage here? Yes or no? That gives me a divide. Do I have voltage in front of it or behind it? Yes or no? Based on how my circuit is developed, am I going to the one side of the circuit, or am I going to the other side of the circuit? Just by seeing, do I have voltage here? Then I can move it over here down line. Do I have voltage here? Yes or no? Should I have voltage here? Yes or no? What happens when I push my button? And our multimeters are going to come in handy when we're doing our testing. Here, I've got my connection point set up right here on my 24 volt, on my normally open connection point right here, positive. So when I activate either my NTS, and here I've got it activated, I'm sending electricity into my common point, which feeds it into my power, or which I've got an LED lit sitting off to the side here, but I power into my strike, and I can see right now, when I power my NTS, I've got 24 volts coming into it. Learning how to use your multimeter is critical steps of troubleshooting. Understanding, am I working on a normally open circuit? There's no power here until I push this button or I activate my wave switch. When I activate it, I send a surge of electricity through it. It gets to my strike, and I can measure it off of my multimeter. So learning how to use our meter is critical. This is measuring for voltage, and we're setting our meters so that I've got a negative down here. Here's my negative sitting off my negative connection point here. And there's my positive point where I'm firing off and sending power into my electric strike. Amperage. Amperage is the next one. We have to learn our understand. Amperage is very critical to us. And most people, if I don't have voltage, I'm not going to have amperage. So there's kind of that's why we normally measure voltage first. If you've ever used a multimeter, you learn how to measure voltage before you measure anything else. If I've got voltage there, how much voltage do I have? Remember that 10%. If I'm within my proper range, if my voltage is down, my amperage is going to be down as well. They flow together in DC power. But if I'm going to measure amperage, am I getting enough power to that product right there? Strikes, maglocks, whatever it is. Am I getting enough power there? And we're going to find that information in literature, and I'll show you that in just a minute. Okay. But amperage is the flow of the electrons in the circuits, or the amps. We can see the measurement up here. We have information here on how much we expect to see. And I'm going to show you that. We're going to show you in the literature. How much voltage am I expecting, or how much amperage and voltage am I expecting to see in your literature? But to measure amperage, you have to open your circuit. You're going to open your circuit and drop your meter in series with your circuit. So you're going to open up a circuit. Here's my negative sitting down here. That's secure as it is. I open up my connection point between my switch and my lock, and I drop my meter in series. My multimeter is set up here. And this is, maybe at some point we'll do a class on just multimeters, on how to use a multimeter correctly. But learning where is my multimeter set. Right here, my multimeter is set as 200 milliamps. It means I'm expecting to read less than 200 milliamps when I measure that circuitry right there. If I don't know how much amperage I'm going to measure, then I need to move my plug from here over to the 10 amp setting. And I need to move, my meter is going to go into the 10 amp setting here. So here again, in our basic class, we talk a little bit more detail. This is where getting into our literature helps us understand how much amperage are we expecting to measure? How much amperage are we expecting to measure? Here I'm expecting to measure 0.220 amps, 220 milliamps, which means my setting at 200 milliamps right here would not be correct. I need to move my dial to the 10 and move my plug over here. This is from the literature of a 1500, 1600 electric strike, the solenoid for the 1500, 1600 strike. How much does it need? How much does it need is important. I had many people ask me, explain inrush current. Inrush current is when you're sending electricity to a product. that first rush that hits it, that is your initial surge. And that surge is often higher than where it's going to be when it comes to a holding capacity. So let's say I take and I want to unlock my front door. I've got an electric strike on my front door, and I want to unlock it for an hour. That means I'm going to send that strike an initial rush to unlock it, and then it's going to drop and hold. Continuous duty is where I'm going to hold that power for a relatively short period of time, usually oftentimes maybe up to 8 hours. But when you put a solenoid into an 8-hour period of hold, the solenoid has a tendency to gets warm because it warms up. The solenoid warms up to getting the amperage over a long period of time. That's one of the key areas where I always recommend adding a smart pack, and we'll talk more about that later on. But my surge is a lot higher than what it takes to hold an electric strike unlocked. This is stuff we find in our literature. So we have to, this is where, if you go back to the resource center will take us back into that library. Measuring for amperage is going to be a little bit different here. Here again, the nice part we do on a lot of the products here. So here's my electric strike here again. Here's the back printing on the back of that electric strike. So I can configure most of these products at either 12 or 24 volts. My amperage draw, when I go from 12, 450 milliamps, that's 0.450, 450 milliamps. When I convert it to 24, it goes down to 250 milliamps. When I look at my meter, I need to make sure it's configured in the proper setting. How many milliamps? I'm expecting 250 milliamps. I need to set my meter in the 10 amp setting here, and my probe will be in the 10 amp setting. I now have opened up my circuit. So I opened up, so here's my original normally open here. I put a little jumper off the side of it. I tied that into my red probe here. That's my in, so that's into my multimeter. And then my return on the other side of it, completing the circuit. So I've dropped my meter in series. I opened up the service connection, so that's my feed from my throw to power it. And that's my input into the strike. Here's my negative return sitting right down here. My negative return is still intact. When I fire my button up here, I'm now sending electricity to the connection point, into my meter, through my meter, back through the rest of the backside, and then into my strike. And that is how many milliamps I'm reading. I am within 10% of what I'm expecting to see. When I drop out of that range, then I have a problem. And oftentimes we think, if my amperage is low, is my voltage low as well? So it's part of understanding the troubleshooting process. And we have to consider at all times how important our connections are. I've shown you some different connections above, but how do we put those connections together? Here again, we go back to giving our technicians the proper tools to do the work on initial installation and on service and repair. Do we have certain things like grommets? Are we getting a rubbing and a chafing on our wires? Those are simple things that create troubleshooting issues for us. Do we have the proper gauge of wire? I've got a whole bunch of different gauges of wire up here. My 22 gauge wire is sitting right here, right there. That's a 22 gauge wire. Average strand count in a 22 gauge wire is 7 strands. Sitting right over here, well, that is my 18 gauge. 18 gauge average strand count is going to be 10 strands in that count. If you start breaking off strands, you're reducing the flow of electricity. When you start having bad connections and connections where you're going to have different problems up there, you're going to have additional resistance. The loss of strands creates resistance. Bad connection points create resistance. We can measure this with our multimeter. Do we have the proper gauge of wire? I think a lot of times when we went out and took over an account from someone else, one of the biggest problems we found is they were using the wrong gauge of wire for what they're trying to power something, and they're having power issues. You start breaking strands off, you're going to have more problems that come with it. Learning how to use your multimeters. But one of the other biggest things that we can do when we're talking about resistance, especially when it comes to an electric strike, we are now seeing our first electric strike coming out with a motor. That motor's coming out very quickly. When you're going to see it here in just a little bit, I'm going to show it to you. But most electric strikes, electrified lever sets, and probably at least half of your electrified mortise lock sets are still solenoid. But solenoids have pressure to them. And what we can do is we can use that resistance down here. We can either use resistance or continuity to measure resistance. Solenoids are taking that spike. So think about that inrush that's spiking our solenoids. And you can see our factory alone in Phoenix, Arizona here, we've got, I think last count, around 30 some different solenoids that come out of our factory. But we can measure the resistance of that solenoid. All solenoids have resistance pressure to them. When they start dropping out of range, then we have a problem. So here I've got a bunch of strikes, and these strikes here, the solenoid with them have a designated value, how much resistance the solenoid has. Some of them are 50, some are 100. It can be all over the board depending on the solenoid you have, but we can measure resistance. We can use our multimeter. When you see the connector points, these guys right here, these Molnexes, understanding there is a way to measure resistance on these different products. Understanding how you're configuring your multimeter to measure the different products here. Over here, I've got an electric strike here. I'm working off the Molex connector directly off of the strike. And you got to keep in mind is that if I'm going directly into this connection point right here, I'm going to see half. I'm going to see half of that value. So, 96 divided into roughly, 48.9. I'm getting the proper value. I'm going to measure that on both sides. I'm going to measure 1 and 4 and 2 and 3 to see both sides of the electric strike, and do I have the proper pressure? If I go and put the 12 volt on the top up there, well, at 12 volts, my range of resistance I'm going to see is going to be different. 12 versus 24. So depending on which connector you have on there, you have to know which value you're going to look at on your multimeter when you measure. You have to make sure your multimeter is set up in the proper configuration. Okay. Notice up here, I have 2 separate solenoids in this product. So knowing what we're looking for is important. Okay. Measuring our products, understanding how to do proper testing. Here, you can see I've added on the connector right here. I've added on the connector. I should be 96. I'm at 94.5. I'm within my 10% range when I'm measuring with a multimeter. Different things we learn to test. And keep in mind, that's for all solenoids. All solenoids have that capability of being measured. You just got to figure out how they're going to be measured. Other places, here again, we're going to go back to our multimeter again, checking these points. How are we getting power or electricity to something? If I've got a double set of doors and I've got an electric strike in a fixed door, I'm going to probably have a transfer hinge of some form. And we can have problems in there. I'm not the biggest fan of the hinge transfer hinges because that's a real tiny, fine wire. I prefer the bigger ones up here. But with those, here again, I can use my multimeter. I can put it in continuity down here, and I can see, do I have resistance flowing through my wires? Over here, I've got a hinge. You can see the small gauge of wire that we're using. And here what I did, you can see I twisted in a couple of different pairs of wires together, and I'm still getting 0.4 points of resistance. And keep in mind, I want that number to be low. The higher the number on the resistance goes up, the more resistance we have to electricity flowing through it. The smaller the gauge wire, the more resistance we have to electricity going through it. And as Russ put in the chat, I'm normally going to use a gel-filled beanie. I want to keep the gel-filled beanie in there because I want to keep moisture away from those connection points in the future long term. If I've got a real heavy area, I'm going to show you some different options here in the future. But learning how to measure resistance is critical. Learning at what configuration. How do I have these products set up? Are they standard fail secure? They only fire once to unlock the door? Or am I putting it into a continuous duty operation where I want the door to be unlocked for longer period of time? If I'm going from 4 hours, I'm unlocked 8 hours. I'm going to energize that solenoid. The smart pack is really designed to be able to put in circuit to be able to help clean up power issues, to be able to protect the solenoid in the long term of the product. And that's where you can take that warranty from 5 years to 10 years. A smart pack is designed to work for anything up to 750 milliamps on a solenoid only. A smart pack does not work with a motor. But in that smart pack, you'll be able to see, if you look at it, download it, you're going to be able to see there's a lot of advantages that come with the product. We have a built-in bridge rectifier. We use a lot of built-in bridge rectifiers at gate operators. So at a gate operator, a ground operator, they usually have a utility outlet. I can take the smart pack and we can use it. It's got a bridge rectifier to convert from AC to DC in the field. We'll talk about some of the other accessories here in just a little bit, but a built-in surge suppression. But if I'm going to put something into a continuous duty, I want a smart pack on it. I'm going to extend the life of the product over time. It's also going to help clean and float out high voltage. So if I've got high voltage that's hitting something, I want 24 volts. If I'm hitting something at 26, 27, 28 volts, and I can't get it down, I don't provide power to it, somebody else does, I want to take the smart pack, I want to put it in series. It's a lot cheaper, one, to replace a smart pack than it is to replace a $400, $500, $600 product. But it can take that 27, 28, 29 volts and drop it back down to 24 volts where I want it to be. So it's got a lot of advantages. If you've got a electrified lever set that's getting warm or really hot, oftentimes there again, I may go look, see, can I put a smart pack in series with this? Because a motor is not going to heat up like that. Solenoid will get hot and warm. Can I put a smart pack in series with it of 750 milliamps? Yes, we can. So here again, we have different options available for it. Understanding our basic products. We put, as manufacturers, we put a lot of different products, a lot of little accessories. And when we talk about accessories, we're talking about resistors, capacitors, diodes, and MOVs. They're there to protect circuitry. They're there to control the amount of electricity that's going to hurt or hit a certain product during that inrush period. If we work, we have to understand the basics of these, and we go through a little bit more of them, especially in our hands-on classes. We'll talk about them. But resistors, you know, when you see a resistor in there with all those little multi-band colors on it, those are important. Those are set resistance levels from the factory. We have to make sure we have the proper product or the proper resistance in our circuit. If we pop one and it goes bad, we can measure it with our multimeter. If I need to replace it, I need to measure it with or replace it with the exact same value of it. You know, we have capacitors out there. These are things that help control the electricity. It takes the electricity in and it slow releases it into the product. Metal oxide resistors. These are designed to stop a kickback, the electrical kickback that can happen. I send a spike to I send electricity to something, it hits the end and it wants to kick back. An MOV is designed to stop some of that kickback. And diodes, a diode is a one-way flow. Here again, this belongs in a circuit somewhere. It allows electricity to go through it without going backwards through it. So here again, understanding what we're working with. Circuits and switches. We've got to understand relays and how they work and how they function. Last week, we went through a lot of the switches that we talk about. It's important that we understand them. It's important that we know how to test them with our multimeters. Here again, the single pole double throw is the most common switch we find in the industry out there today. We find it in a lot of our smart products up here, most common on the smart product. We find it under a desk. We find it in motion detectors. We find it in wave switches. We find it in timers. Understanding how that switch works and how it functions is critical. Let's talk about some of the other different issues we're going to have out there. A lot of these issues can be, human caused, caused by, something doesn't work. They don't know how to test it. So they replace it or they figure out how to, collude it together. It happens from doors being damaged over time, putting pressure and preload pressure against the latch, connection points. Are these done neat and clean? Something like this right here, that could have been taken care of with simple, a little bit of black electrical tape across there. Understanding when do I use weatherproof connection points? How do I seal them up? Different there again. This is where I take the high-end technicians. They need to know this stuff. They have the parts and the pieces available on their trucks. Having the components we need is very critical. And understanding, I need to take something like this. What do I do with it? Oftentimes, my service technicians are going to be doing some of these fixes and the repairs. This was created by, I'm more than likely going to say it's going to be a maintenance or facility person. He had to get it working that day. But we've got this same type of frame right here. What are my options? I know I'm going to have problems. I've got impact issues. I'm going to put the proper strike in there. I've got a lip plate to cover that front beginning right here where my latch is going to come in. I want to secure it in there tightly. Different options that we're going to consider. And another big one was strikes, especially when you're dealing with aluminum. When you're dealing with aluminum, you need to make sure that you're using a little bit of Loctite on it. I don't want the heavy stuff. I want more of a medium level. So if we're going to use the mounting kits up here, always use 2 screws. Always use 2 screws. Never use 1 screw when you're using the tab kits up there because they're going to vibrate loose over time. and the blue Loctite helps to keep it secure. Here I have one. This one here, I was working with I was out in San Francisco a few years ago, and I had to do a class, and this was a high-end industrial or a high-end IT business operations facility. They had literally different operation departments within this facility, and what they realized is their own employees were creating problems. That electric strike wasn't functioning correctly because there was so much junk shoved into the pocket in there, the latch would never go into it. And I was out there doing a training class. Said, hey, can you kind of give us a suggestion of what to do? So we had the Adams Right 7400 strike right here. And what we talked to them about was going in and adding a latch bolt monitoring capability. So I would monitor if the latch was in the pocket. So if the door was closed, the latch should drop into the pocket. If it didn't, well, then I had set up in there, if the door was open or closed, I could see it with the door contact, which was separate. And if my door was closed and my latch was not closed right here, my circuit wasn't closed, I had a little screamer that went off. So the next time someone tried to shove something in the pocket, the door was closed, but my latch wasn't properly done. I set it up so that they had a screamer that went off, and that stopped it really quickly because everyone is like, oh, they knew exactly who put it in there. And it's all about understanding how to wire and trigger everything to make sure it works correctly and cleanly. So here again, it's just experiences as we work with different customers. But we can create a lot of our own problems here. You know, wiring something like this, time and patience. This was done because someone did not do a proper site survey. Here I had cement in the back of this frame. It was cemented hard. Someone did not want to deal with it. So they went and kind of did a shortcut and just kind of drilled their wire out. Yeah, it might have been, you know, it's just ugly. You know, here again, whoever did the site survey, they did it wrong. They created and set this up wrong. Some customers will just say, you know, I'll just deal with it, whatever. But I'm not going to let that fly. You know, we can create a lot of damage when it comes to working with storefront aluminum. I'm very cautious. I tell people, if you do not know how to work with storefront aluminum, call a locksmith or call someone who has experience that works with storefront aluminum, so we don't have stuff like this that happens. And here again, some of this may be part of maintenance of facilities people. It's not something that I want to see at the end of our projects. You know, if I'm going to go in and work on something like this, I want to replace that entire style right there and make it look clean. Because if I'm going to put a sticker with my company's name on the side of it right there, I don't want people to think I did that workmanship there. I want to have a clean presentation. Here again, here I've got an issue because I may have an issue with my latch being set a little bit. Can I move my bar a little bit? Because my latch is coming in and smacking right here before it ever gets into my electric strike right here. Is there a way that I can, you know, can I do a horizontal movement on that bar a little bit? And some bars you can move and some bars you can't move. But I want to, you know, that's another issue here where this is an issue which may not necessarily be my issue. I did the strike only. I did the access control and the strike. That was created by something else before me. But what are different options? Consider that. Here I would look at, can I slide that bar a little bit horizontally to adjust it? There are other things we can do to cosmetically fix that, but it's still not something we want to look at. One of the big things that we've done is we take a lot of input that comes from the field. You know, if we hear that there are different issues that we have over time, you know, we listen to that and we take some of that input. On our strikes, on our surface mount strikes, one of the things that we heard, you know, is that, you know, some of these parts and pieces might get gummed up inside the strike. The metal shavings might fall down in here, whatever. And so we put magnets up on the top of here. That's a heavy duty magnet, and it's on both sides of the strike. So no matter how the strike is oriented, you're going to have something. We're trying to avoid different issues, avoid issues for you. But a lot of times we can take a can of compressed air and blow out some of the different metal shavings. We use compressed air on a lot of different products. The white lithium comes in where we're dealing with some of the rust components that we may have to deal with over time, especially when you've got an outdoor. And keep in mind, something doesn't necessarily have to be outdoor to accumulate rust. When you get into Florida, you get that high moisture level out there, you're going to have some different problems with humidity and the moisture getting on the products. But the white lithium will help out not too much. It's a simple, you know, small little dabbles of it, small and work your way up instead of big and work your way back down. Because almost with anything else, if you've got something, you can always accumulate stuff that will stick to it until it gets to a lubricating point. So you want to be careful. There are checklists out here. You know, during a site, do the site survey, understand the health of the opening. The site survey is where we begin troubleshooting. If you've got a place that's got a lot of problems over time, here again, you're going to be able to hopefully identify that during the site survey, and that may be the responsibility of the salesperson. If your salesperson is doing your site survey, they need to understand what they're looking at, educate them. We used to always have our salespeople spend time with our project manager or our senior technicians. That allows them to really understand what we're looking for, understand what the technician is looking for. When we talk about doing a site survey, I always tell the salesperson, think in the mindset of the technician doing, think of the mind of the technician who's going to do the installation and the work on it. What are they going to go through? Site surveying, is it the proper latch length? How does the latch and the frame and everything work together? Existing, you know, preload issues, existing hardware, how does it work together? Understanding codes. You know, you may be out there, you may take over a job site and you go out there and you're looking at something and you identify, hey, I've got a fire rated assembly, but I have a non-fire rated product in here. Do you have responsibility? Do you have responsibility to identify that and get it corrected? Anybody want to tell me that? Any yeses or nos out there in chat? Do you have a responsibility to identify that and get it corrected if you see a code violation? Anybody in chat or want to speak up and say yes or no on that one? If you keep in mind, he or she who touches it last owns it. You go out there and you service something and it's not code compliant, you better identify it and get it corrected, because if not, the code official comes out there and finds it, they're pointing a finger at you because you're the last one who touched it. It's your responsibility. Know your lock sets, your strikes, and understand how they work together. Ask questions if you don't know, and go back to use our customer support app. Ruben's sitting on the back side back here. Ruben's team is phenomenal for helping you. If you're out there at the job site, take a picture, take an image, call us up, talk to us, and live stream something to us. Let us see exactly what you're looking at. Ruben's team will normally pick up in under 30 seconds. You know, that is phenomenal, because I remember waiting for hours and hours and hours on hold, hoping the right person would pick up the phone and be able to help us out. One last thing I want to be able to talk about very quickly here is the brand new ES100 electric strike. The most common way that we get to talk about it here is there are three different versions of the ES100 strike. A 1-to-1 version, and then we go up into the 1-to-8, 1-to-16, 1-to-32, 1-to-64. I mean, they're getting bigger and bigger and bigger. But from here, what we can talk about, you know, we talk about the 1-to-1 unit. That's where we're dealing with one electric strike, a reader paired with a hub. So you can either select either the 1500 strike or the 1600. You don't get both, you get one or the other, in conjunction with a card reader, in conjunction with a hub. And it allows us to put that hub up on the wall. So we're putting a hub up on the wall that talks to our access control system. It will remote talk to via wireless communication down to our hub. In the hub, or in our card reader right here. So we communicate from the hub to the reader and the reader to the hub, back and forth. I've got batteries that are in there, and from that battery, I can now energize an electric strike to be able to open up. This is our first generation of a motor. These are motors in this version of the electric strike. They're equal strikes. We're using less electricity. Green is huge right now. We're going more and more into green. So I put a valid card to my card reader. It communicates up to my hub, to my access control system. It goes all the way back into my access control system. It says yes or no. If I come back and say yes back to my strike, it sends a shot of electricity to my motor inside my strike here, and it allows it to open up. Wireless communication from my reader to my hub, 1-to-1 configuration. If you can get certified, you have to work with the DSS team of ASSA ABLOY. If you can get certified, you can go up to buy the Imperial line of product. There's a whole line of products that goes with it, where you can go one hub to multiple products downline. You have to be certified to get into that program. But here you can see the basic configuration. I've got no wire here except for the wire between the reader into my strike. And with this, I can still get in conjunction with the monitoring, so I can monitor the latch and the door position switches. So there are different options that we have with this. Wireless configuration here, or wireless configuration to the lock set, Communication is wireless from the reader to the hub, back and forth, telling my strike to either unlock or not lock. It is brand new out there. You can order it now. These are phenomenal little products. So just keep an eye. We're continuing to advance and grow what we're working with. Okay, support our apps. The Built app is out here. Phenomenal support app. This is for men who do not like to read instruction. The Built app has been around now for about 4.5, 5 years. But imagine an app that in 5 to 10 second snippets that will show you how to install something. Ossobloy right now has around 95 products listed in that app. And there are thousands and thousands of other products out there. If you're a do-it-yourselfer and you go to Home Depot or Lowe's and buy something, look on the side of the box and it'll show you that app symbol right there. If it's got that on there, it will show you how to put something together. I remember how many times I put together different things and my wife would laugh at me because I would not read the instructions on how to put it together. Imagine having an app that works on your mobile device. It is designed for your mobile device. iPads, Apples, any of your Apple or Android, whatever you have, phenomenal app. And probably the better app yet, when you need support out there from tech support, 10 minutes. I have a 10-minute rule. If you're working with any of our products, Ossobloy, if you can't figure it out in 10 minutes, reach out to us. Let us help you. Ruben's team is phenomenal. They're going to pick up the phone very quickly, and they're going to help and support you. And the best part is we pay attention to time zones. 8 a.m. East Coast time, we're open and ready to work, to 5 p.m. Hawaii time. So if you need help in between time, we've got somebody there. If you're a late night tech in Washington, D.C. and you need help, more than likely, you're going to be able to catch us for an hour or two after that time. Clayton, yes, you can download the presentation. Katie later on today will post out to all the, whether you attended or not, whether you missed the class or you attended in person, Katie's going to send you out an email later on. It's going to give you links to go and download this presentation. And with that, we're almost done. I'm going to show you our contact information right here. If you need to reach out to us, here's our information, our email, our cell phone information, customer support and tech support. It's all right here. But if you have the app, if you have this app right here, you just touch. You touch into the app, you touch into where, find the brand you're going to work with, and then you touch to go ahead and communicate with them. They're there to help and support you.